Hello, let me continue where I left off in the last session. We started with trying to make a small enclosure which can house that small DC-DC converter which is used for running something. Actually, I have a 12 volt battery. I wanted to connect it to a modem which works from 6, 9, 12 volts and so on. So, then we managed to get this small thing. Now, if you can kindly see this thing here, you will see a series of pictures which you remember this is where I started with, and then we went on trying to make various things, and then at one point, if you remember, I stopped here saying I try to now make a small what you call a corner support, and then I turn the printed circuit board over it and get it. Then when I went to the what do you call to the printing machine, or my colleague Mr. Singh has told me that while in principle this is okay, this is an overdue. We can manage with finer features and so on. You see here, I have an extremely compact and small unit. This is the type of features we are thinking of, and they are very small. We have a small knob here, and same thing here. We have some places for various things which are extremely small, and this thing, especially if you see a small this thing here, this is very tiny. So, his feedback was saying the features are gross. So, all the finesse of making something in plastic is lost. So, you see the wall thickness is very small. In fact, there is a small lip also here. So, that eventually when the box is made, probably the box will sit nice and flush like this. So, for such a item, it is not correct to give such gross features as are there in that. So, if you look at those features, you will notice that they are not they are not in what you call proper compromise, or what you call proper design. So, further, if you remember, we wanted to check whether the a smaller thing like this with two supports here is better than having a complicated what you call circular feature like this. So, after due consultation, we have found out probably this whole thing is a overdue. We need to simplify it a lot. So, I went back to the what you call drawing board and try to make something finally, this is a simplified device of the same thing what you saw there earlier. So, if I now try to you see several features have been added. One of them is that at the corners a relief and a step which was given has been removed, and all that semicircular things have been removed. And similarly, when the wires of that what you call DC-DC converter need to be taken out, they need to be taken out from the sides. A lot of reliefs have been given. This is the simplified version of the same box which I have shown earlier. So, if I rotate it, you will see that and then there is a singular, after having measured the bottom and the various surfaces and all that, finally we have an enclosure which is flat, which is simple. So, this is where and this has been loaded on the machine there. Downstairs the whole thing has been taken and try to load it on the machine. This is a transparent what you call representation of a rendering of how the box is going to look. For the purposes of our illustration, the thickness of the walls has been shown as 2 millimeters here, but actually the actual thing in the drawing is only 1.4 millimeters. 1.4 is very thin. This is typically about as thin as these items, and it is strong, okay, quite strong. It broke already, it broke even before I pressed. So, if it is supported in both places, it is quite strong. So, after having done this, this is the other side of the box, and this is only for the purposes of illustration that that box was big, and actually you see here the wall thickness is a little smaller. This is directly loaded on the what you call the 3D printing. We have a patch program which starts the point here. So, my colleague is now working on that device there, trying to load it, and finally once the whole job has been loaded, depending on the sophistication of the system and professional features of the system, you will end up with a beautiful program which will show you how things are made. So, if you see here at the bottom, we have a line which is both a bottom timeline as well as number of slices, how it is going to build and all that. The bottommost is obviously the very base point of it. You see here that same what you call filament moves across and tries to fill the whole thing as much as possible, and that whole square hole also, no, if you go a little closer, you will notice it is almost like a puzzle. See, it starts here, goes here, goes around and all that, and fills it like this. Same thing about all the features here. So, depending on the build up or how this machine builds these surfaces, it is possible for you to give 45 degrees plus or 45 degrees minus type of lines, and to see how well it builds. Here the intelligence is built into that machine. Next layer is this, all the filling up layer. What the filling up layer does is, see, if you the building layers are shown here, you can move it wherever you like, take the various slices. After the bottommost layer has been built, next comes the, if I go back to this box here, you remember this, in the 4 corners there are vertical grooves given, and in the other places this is where the whole thing supports itself. Now you see, as much as possible we try to maintain the minimum amount of width here. So, we have found after a little bit of practice and consultation with the manual, 1.4 mm seems to be strong enough, and 1.4 mm also is the one which reliably the machine builds by having 4 passes in all. So, it becomes reasonably fused, well strong and all that. So, the next picture will give you, as these things build up, it keeps on building up. You see, it is here at this point, these things are all along, layer on layer on layer, this thing builds up, and finally after this nearly coming to the top, you will see that for the first time, no, these 2 gaps have started being built. Mind you, this is the way that each layer the material is being built up. So, just below that you have the other support of the other material. So, beautifully you can make out how these things, actually no job has not been sent for what you call melting or the build up or the printing. In the machine it's, I mean in the software itself, no, I can see if there are any problems, and the next picture will show you it has finished. It has happily printed that features, and we are almost coming to the end here. Let me see if it is a surprise, if it has finished it. Yeah, to the almost to the fag end, and finally the job, printed job is likely to look like this depending on the material you use. If you use a grey colored what you call material, our job is going to look like this. One of the things you see is we have minimized the amount of movement and made it easier to build and try to reduce the total amount of material and so on. In spite of it, it shows so many grams. In the beginning I have shown you. So, this is one of the jobs you see here. Total mass is only 5 grams. So, we have achieved to make a really light product, and only problem is because of the what do you call amount of finesse we are looking for. Print time is long, 1 hour 22 minutes. Why? Because we have given a thin section and then we are using one of the thinner wires to see how well it builds here, and other data like what is the plastic volume is given here. So, related to this, from here the mass is calculated and the dimensions of the object are also calculated. So, and this comes to the most important thing. One of the things we need to do in any of the 3D printing what you call setups is find out where to place the part such that an accurate, easy to release piece comes out. In our case, later on in the what you call in the video you will probably notice it, we have lead screw at the back and a cantilevered plate which keeps moving up. For this, for support and all that, they have given things here. It is very logical because of the type of printing and all that. No, you select where you want to put the part. If you keep it too close, there is a problem, and if you keep it too far away, there is always an accuracy problem. So, by a little bit of practice, we have managed to locate this piece. And one more reason is, if you want to take multiple prints without disturbing the original location, I can now populate it here. I can go back another 2 more rows here, 1, 2, and then this side, no, 1 column here, 1 column, so that 9 of them can be printed usefully. If the part is a little bigger, we need to print more of them. And right now we could not locate that particular command called the step repeat command. Most of the packages have that, by which if you load one piece, you can make it step repeat. Alternatively, when you create the drawing itself, you copy paste several places. After you copy paste on the several places, you upload it. Only disadvantage being the drawing becomes big, everything becomes, all the vectors become very large, database becomes extremely large. If you have a step repeat function built inside, you need to give a little less what you call, only one instance of it can be taken and the whole thing copies itself there. And the advanced programs allow you to manipulate the object on the screen. So, what you carry from one place to the other on a pen drive or send it by mail is going to be small. Later on we decide how we stack them. Some of the places how we orient and stack them also makes a small importance. So, I will later on when we go back to the what you call to the machine, I will try to show you other things. You see here in the other monitor, just like that I went and gave a small picture, a small query here saying 3D printed box for a Arduino. So, anything you want, it's a beautiful ordinary boxes, I mean Arduino boxes are here. You see here, this is one of my favorites. So, what is so important about this? The important thing about it is Arduino is a developmental kit. See this, no? Arduino is a developmental kit. So, to help in building things around, similar to what I have been doing, people have gone out of the way and then built very useful things. Oh, see this here, we have the printed circuit board and there is a place for the power supply jack here, which is the power supply jack here. I expect that this is probably the USB or switch input, and then I know we have the 2 rows of connectors here, and then see something else here at the top. You also have a place for the cell here, battery, and you have a cover which takes care of all of it, and you have a full fledged Arduino case set. So, you can place all these things inside. This is where you can either buy it or rent it or whatever it is. And what is this? This is a wish board. They have also integrated a wish board into it. Now, if you go down, you see here very beautiful 3D printed objects are available there. It is possible for you to skate on your Arduino board. Seen this, no? So, we have a nice what do you say, ready-made project enclosures, that is that is there. So, the other green colored hinge I have shown you is also from this Thingiverse, saying a universe of small things, no. So, anything you want, no, all this stuff is easily available. I am very and you see most important is that most of these kit, I mean the source or the things are easily available for you. See here, complex electronic item can easily be built on your, if you have a printer yourself you can print it, alternatively you can buy it. So, something here, printable Arduino protection box. A few things you will notice here, which I am proud that we also parallelly discovered it. Seen that? One of them was, hey, where is my board? It is here. Remember I was talking to you about we should have square openings and so on compared to round openings. In the case of our normal workshop practice, it is customary for us to make circular openings, but in the case of 3D printing, it is much easier if you come with a square opening, because the way that tool travels and it makes things very convenient and easy for us. So, I have here an example of whole thing, and then if you remember earlier on I was talking to you about the USB this thing. This is probably a type I am not sure, type B or something. Then you have a power socket and you see here how these things are raised, and perhaps the most important thing here is the way the small thing is sitting here. And if I download and if I enlarge it, you will probably see, I will try to save the image onto the desktop and then go back to the desktop and see. This is what I was trying to tell you earlier. Can you see here? The reality of 3D printing is these layers are visible all the time, and contrary to what they have been showing you in all the demo parts, real parts are going to look like this. In fact, you have seen here inside there is a very rough surface, but this is reality. So, functionally it satisfies all your purposes. there is no issue about the functionality of this. And then later on you need to now decide whether it is sufficient for you or what you want to do with it. So, non-stop, really huge amount of data is available. Now, have a look at this. See this. This is only the what should I say, the 3D solid model that is there, not the printed one. What you saw there was the printed one. If you see here, everything looks hunky-dory and smooth and so on, but the reality is in this corner. And then if you see these openings, we have the problem of they are not smooth as we expect it to be. Same thing about the top cover also. After the top cover sits on this, and then you see here what has been done. They have provided 4 small bosses here, so that the printed circuit board directly snaps onto these bosses. So, you take it here, snap the PCB onto this, and directly on top of it, you snap the other thing on top of it. And you see a small red colored something, they have made a gap here so that you can push it inside. It acts like a door. This top one is for the door on top, this bottom one is for the door at the bottom, and I do not know the English word, I do not know if it is called as spigot or something, that is useful for locking it. Now, going back to we have a very large number of these projects all over the place. It is relatively easy for us to build, make anything. Now, kindly see the small samples which I brought here, this one. You see here, I have a, oh, I hope it belongs to this. Oh, it does not seem to belong. Oh, yes, it does belong to this. Oh, I have 3 variants of it. It is even better. See, we try to make a small switch like thing. Can you see here? We started with believing what we read everywhere, saying will we make it like this. So, one of the thing you will notice is there is a gap here, you can see that. So, if you want to make a springy layer, if you can make a nice overhang, you see here, I will just show you, you see, observe carefully, can you see? This sort of what you call minor tricks of the trade you need to do. So, you can have a springy part. This in turn goes and touches something else inside. So, this was supposed to be made for a energy harvesting switch. So, we have a completely assembled switch module like this, where this is a completely remote device, but unlike the other remote devices, it does not have a power supply. I just press it a couple of times, the charge takes place and so on like this. I am sure a lot of you people must have seen these thumb push for a, we call it a doorbell switch. I think Americans calls it a thumb push. So, one of my colleagues, Dr. Prabhakar, works on energy harvesting. So, this has been made by my colleague for the same purpose here, and in fact there is a beautiful movement inside, there is a spring inside, tremendous amount of detailing has been done, and if you carefully, I do not know from there whether you can see it or not, lot of mechanical and electronic stuff has gone into it. Eventually we have a completely functional switch. If you put a spring inside, you see whole thing moves, and this is typically a fully functional 3D printed item, which it is nice, you need to see it. And now if you see these, now we come to the other point, how do we attach these things to each other. So, your what do you call, I will say your guess is as good as mine. So, in this case, yeah, can you see here, there is a small circular opening here, there are other things, and then in like a conventional way you just take a, what do you call, yeah, this belongs to this, take a screw and push it. On the other side you see lot of detailing is there. This detailing you need to work on by directly on the computer, that is when things are really convenient and easy for us. So, now you come into some other areas, which I say are a little both possible and not possible with our this type of a design. See this here, I will see if I can press and actually it goes and opens that, it does open that. Now, for short we may not be able to make this in transparent materials. Building in transparent materials is tough. However, something which is related to this 3D printing is the laser cutting. We have a, I mean, as part of this, if the machine is ready, we can show you the laser cutting also. Here what is done is flat acrylic sheets are taken and they are cut using a laser, and then when you assemble the whole thing, we have a beautiful thing, what you call beautiful functional enclosure. Only thing is, sometimes acrylic is useful, sometimes you do not want things to be seen inside. So, wherever something is flat and absolutely there are no undulations and no detailing like at a show inside, probably this is best for a full 3D printing exercise. Else all the windows and all that you probably need separately to make, like which happens to this here. If you see this beautiful device here, the whole thing can be printed without any problem, except that this small window probably you need to insert either a glass or a, yeah, this is a simple molded acrylic thing. And now the good news is even transparent materials can be easily 3D printed. So, this is one of those things. And having come so far, why should we restrict ourselves to only simple shapes? So, somebody has built a beautiful, nice, you see here, they have tried to play as much as they want with a attractive pattern on top of it. So, now you go back to architecture, or now if you go back to anything including product design and including our apparel design, including anything, basic functionality is one. The element of aesthetics and the element of novelty also makes a lot of useful proposition and variation in design. So, they have built that little bit of novelty, and things like this are very easy to build with a rapid prototyping device. So, it's nice to see. And that being where it is, you see we have a nice simple enclosure for RF and anything we want. There is a place here, probably it is a what you call MCX connector, and without worrying too much about optimization, probably they have directly taken something which is similar to what we have in the injection molded devices. So, in case you have an injection molded device, that is what I showed you with, this is taken directly from a electrical switchgear house wiring, and after having modified in everything and all that, a vastly improved directly printed thing has been made. This is as part of another project. I thought I will show you. You have seen this, no? Is exactly what this picture shows here. This picture what it shows is they have taken an existing 3D what you call, I am sorry, injection molded part, and then they have tried their best to do something else with it. Now you see here